All right, for today's lesson, we're going to be talking about operations, adding, subtracting, and multiplying, and composition of functions. So basically, you're going to have some notations that you're going to need to pay attention to. So when we talk about a function, so f and g, they could be named anything. They give them different names just so you know that they're different functions themselves. So if I say f of x, that's the name of a function. Technically, it means y, it means the output, but it gives it a name so that you know which function I'm asking you to deal with. So for this one right here, it says f plus g. So that basically means that you're going to take the f function and you're going to take the g function separately and you're going to add them together. Okay? Same thing with subtraction. So this one says f minus g. So that means that you're going to take the f function and the g function and you're going to subtract them. Now the subtraction you're going to have to be very careful with, and we're going to talk about, because you're basically going to be subtracting the whole g function, not just one piece of the g function. So then we have multiplying. Now multiplying, you have to pay attention to the symbols. A lot of the times, instead of having the little star, it'll be like the closed circle, or it may just put the two functions side by side without anything in between them. So just keep that in mind when you're looking at multiplication. So when we look at multiplication, this means we're going to take the whole f function and the g function, and you're going to multiply those two together. Now, we're not going to be doing division right now because division is going to require a little bit more, and we'll get to division more when we do rational functions. Now, composing functions. Composing functions means you're going to plug one function into the other. So the key is that, how do you know you're composing? Well, that open circle, so obviously it looks like a O, but it's an open circle that basically, when it's stating this is saying that you're going to compose f of g. So how does that work? Well, when you look at it, if you see the open circle, that means you're going to take the g function and you're going to plug the g function into the f function. Now, what we're really going to focus on is we're going to focus on number composing. So we're not at a level yet where we're ready to actually compose with a whole function. So we're going to learn how to plug in numbers into the function. So when you look at it, the g is in the parentheses, so you're going to put g into f. All right, so when we look at this one, the f, this is g of f. So f is going to get plugged into g. So again, if I look at this, f is in the inside of the parentheses, so we're going to wind up taking the f function and plugging it into the g function. Now, one of the things that students get confused about the most is the difference between multiplying and composition. So with multiplying, you're either going to have a closed circle or it's going to be side by side for multiplying, and then composition, you're going to have the open circle, or you're going to have one function plugged into the other. Okay, so we're going to start with operations and then we're going to go into composing. So right here I have two functions. I have the f function and I have the g function. So I'm going to kind of color code here. So I have the f function and the g function. Now this one says to add f plus g. How do I know I'm adding? I know I'm adding because of the addition between them. So we're going to take the f function, which is x minus 5, and we're going to add the g function. So the g function is x squared minus 2x minus 15. And at this point, when you're doing addition, you just combine like terms. So for this one, we're going to combine, let's see, what do we have? So we have the x's that we can combine together, and we have the numbers. So right now, currently, we don't have anything that we can combine x squared with, and that's okay. So we just bring it down. So then what we're going to do is we're going to combine the x and the negative x squared. So x and negative x squared, negative x is going to give me negative 1x, or just negative x. And then for the other one, we have negative 5 and negative 15. So if I combine those two together, that's going to give me negative 20. And that's my new function with addition. Now, for this one, we're going to do actually 2 of these because it's going to make a difference. When you're adding, you could do f plus g or g plus f and you're going to get the same answer. But with subtracting, you're going to get completely different answers. So for here, remember f was in blue, so this is saying that we're going to take f and we're going to subtract g. So if we take the f function, so the f function is x minus 1, or excuse me, x minus 5 minus, and then we have x squared minus 2x minus 15. Now, how do we deal with subtraction? So with subtraction, you're subtracting this whole function right here. So how do we do that? Well, we need to distribute that negative. And if we distribute the negative, then it's going to turn into an addition problem. So this is going to become x minus 5. We're going to change that to addition, and we're going to make this negative x squared, this positive 2x, and this positive 15. And then we just combine like terms. So we're going to have negative x squared because there's nothing to combine there. And then we're going to do x and 2x. So x and 2x is going to give me 3x. And then we're going to do negative 5 and positive 15, which is going to give me plus 10. Now, that was if we did f of x minus g of x. So let's actually do this one where we're going to do g of x. So we're going to do g of x minus f of x. That's going to give us a completely different answer because we're subtracting a different function in a different order. So if I do g of x, so this time we're doing x squared minus 2x minus 15. Because remember, g of x is first, and then f of x is second now. And we're going to say minus f of x, which is x minus 5. Now, we're going to do the same thing where we're going to want to distribute that negative and make it addition. The only difference is this time we're doing it with a completely different function because we are actually subtracting f of x. So if I distribute that, that's going to become addition, and that's going to be negative x plus 5. And then we just combine like terms. So we're going to have x squared still. We're going to have negative 2x and negative x, so that's going to become negative 3x. And then we're going to do negative 15 and positive 5. So that's going to be negative 10. So as you can see, they gave you different answers depending on the order that you subtracted. Now, multiplication. Remember, multiplication is that closed circle. That's how we know we're going to be multiplying. And you may multiply in lots of different ways. I found over the years that to keep it organized, that the box method was the best way for students, but if you have learned to multiply a different way, then by all means do that. So remember, when you're multiplying, you are either going to have this closed circle or they're going to be side by side with nothing in between them. So the box method, basically what is going to happen is we're going to wind up with x minus 5, and we're going to multiply that by x squared minus 2x minus 15. And the box method is really and simply just a way to organize. So some of you may have learned to just distribute multiple times with each term. And again, if that's how you know how to do it, then by all means do that. I think that organizing it just helps it so that students don't miss any pieces. So when you do the box method, you set up the pieces. So this is x minus 5. So we're going to do x in one column, negative 5 in the other. And it doesn't matter whether you set them up in the columns or the rows as long as you keep the pieces together that belong together. So then on this side, we're going to have x squared, negative 2x, because there's minus, and negative 15. And then basically what you do is you just line up your columns and rows and multiply. So you're going to multiply here, column and row, and then this column and row. Then you're going to go to the next one, multiply column and row, and then column and row. So for the first one, we have x squared times x. That's going to be x cubed, because there's technically a 1 right there. So when you multiply, you add exponents. So then we have x squared and negative 5. That's going to be negative 5x squared. Then we have negative 2x and x. That's going to give me negative 2x squared. And then we have negative 2x and negative 5 is going to be positive 10x. Then we're going to go to the next row. So negative 15 and x is going to be negative 15x. And negative 15 and negative 5, that's going to give me, positive 75. So at that point, we have all of our pieces. Now we just need to combine like terms. So when we combine like terms, we're going to look for the ones that have the same variable, same exponent. So these two can combine together, and these two can combine together. So when we finish this, this is going to be x cubed minus 7x squared, because negative 2 and negative 5 give me negative 7. Then minus 5x, because negative 15 and 10 give me negative 5, and bring down the plus 75. All right, so that is adding, subtracting, and multiplying. So now what we're going to do is we're going to do some composing. So composing, remember, is we plug one into the other. Now we're only going to compose with just numbers right now. You'll do composing with whole functions in your next level math class. So we have x minus 5 for f of x. So we have f of x right here. And g of x, we have 2x squared minus 2x minus 15. So remember, when we're looking at composition, we have f of g of x. That's that open circle. So that means that we're going to be plugging the g function into the f function. So we're going to take this whole g function right here, and we're going to plug that whole g function into the f function. So when I analyze this, the first thing I see is in the parentheses, I'm looking at my f function. But this says f of 3. So if you remember that when it's in the parentheses, that means that we need to plug 3 into the f function, and then that'll go into the g function. So we're going to need to do a couple of steps here. So I'm going to start with the f of g, or excuse me, f of 3. So f of 3, that means that we're going to input 3 into the x spot. That is the x variable. So everywhere I see x, I'm going to plug in 3. So I'm going to plug in 3 minus 5. And that gives me negative 2. So basically what that means is right now, this means negative 2. So now I'm going to find g of negative 2. So it's like input, output, input, output. So we're going to plug in negative 2 now into the g function. So we're going to use our g function. So that's going to be 2. And everywhere I see an x, so I see an x here and here, then I'm going to need to plug in negative 2. So I'm going to put negative 2, I'm going to put in parentheses, squared, minus 2, and I have another x, so I'm going to put negative 2 again, minus 15. Now, if you need to put this in Desmos, by all means do so. So if I split screen this, I can put this right into Desmos and do 2 parentheses, negative 2 squared, minus 2 parentheses, negative 2 parentheses, minus 15. So my final output of that composition is negative 3. So when I get my final answer here, my final answer is negative 3. So when I do the composition, I input negative 2, or excuse me, I input 3 into the f function. I got out negative 2. Then I input -2 into the g function, and I got out -3. -3 is my final answer. All right, so let's look at another example. All right, so there was a typo here, but we'll get to that in just a second. So this one is telling me to take g, so we're going to take the g function, we're going to plug in 2, and then after we plug in 2, we're going to take that and we're going to plug it into f, because you see that g is in the parentheses. So I'm going to start with g of -2, excuse me. All right, so g of -2, that's going to give me, so remember our g function was 2x squared minus 2x minus 15. So this is going to be 2, we're going to plug in -2 squared minus 2, there was another x, so we're going to plug in -2 minus 15. Now, we actually already did that in this particular problem. We already plugged 2 into -2 from the previous. So my output here is going to be -3. Now, -3 is not my final answer. Now what we do is we need to take -3 and plug -3 into the f function. So we're going to take f of -3 now. So remember, we got to use the f function, which is x minus 5. So where x is, I'm going to plug in -3 now. Minus 5, and then -3 minus 5. My final answer is going to be -8. All right. Now, for the other problem, this was a typo, so if you'll fix this on your paper, we're going to turn this into a g. So we're going to take this right here, and we're going to rotate the f and the g, because I wanted you to see that they come out to be different answers. All right, so we're going to make this the g and this the f. All right, so we're going to plug -2 into the f function this time. So -2 into the f function, and then after we do that, we're going to plug that into the g function. All right, so we're going to start with f. So we're going to find f of -2. So remember, f function was x minus 5. So we're going to do -2 minus 5, and we get out -7. So now we're going to take -7 and we're going to plug that into the g function. So we're going to find g of -7. So if you remember, it was 2x squared. So we're going to do 2 times -7 squared minus 2x, which is going to be -7 now, minus 15. And again, you can go and plug this into Desmos. Now, I already had this in here, so I'm going to change my -2's to -7's. And my final output is 97. So 97 is going to be my final answer for that composition. See, another typo is the exact same problem from the other page. Sorry about this. So if you will, take this and mark these F's and G's out. And we're going to make this an F here and a G here. So we're going to be plugging them into different functions because it's the same problem as over here. So we're going to start with the G function. So we're going to take our G function and we're going to plug 3 in. And then once we plug 3 into G, we're going to get an answer and plug that into F. All right, so I'm going to start by finding G of 3. So for G of 3, remember it was 2x squared. So this is going to be 2 and then 3 squared. And then minus 2x. So where x was, we're going to put in 3 as well. Minus 15. And we need to evaluate that. So again, I still had the same problem over here in Desmos from before. So I'm just going to put in 3 where the x's were. and I get out negative 3. So that means that g of 3 is equal to negative 3. So now what we're going to do is we're going to plug in negative 3 into the f function. All right, so we're going to take, it's x minus 5. So we're going to do negative 3 minus 5, and that's going to give me negative 8. Negative 8 is going to be my final answer here. All right, so we are done with our composition, plugging in and plugging out with equations. There is a different type of notation that a lot of students confuse with composition, but really what it is it's just telling you to multiply. So when I look at these two, I have 4 in front of f of x, and I have 2 in front of g of x. So this is basically saying 4 times f of x, and then 2 times g of x, and then subtract them. Now, you can separate these in multiple ways if you want to. It's completely up to you. So what I'm going to do is I'm going to do 4 times f of x, which is x minus 5. So I'm going to do 4 times x minus 5, and you're basically just going to distribute there. So that's going to become 4x minus 20. Now I'm also going to do 2 times g of x. So g of x, if you remember, was 2x squared minus 2x minus 15. So again, I'm going to distribute to each piece. So that's going to become 4x squared minus 4x minus 30. Now here's the most important piece here. You have a minus sign. So when you subtract these two, you're subtracting this entire g piece that you just multiplied. So I would go ahead and distribute that negative like we did previously with subtraction. And then that's going to become 4x minus 20 plus negative 4x squared plus 4x plus 30. And then just combine like terms. So if I combine like terms, that's going to give me negative 4x squared. Then I have some like terms. I have 4x and 4x. So that's going to give me 8x. And then I also have negative 20 and positive 30. So if I do negative 20 and positive 30, that's going to give me plus 10. Okay, so hopefully that helps you out with understanding that those are just multiplying and then subtracting. And then finally, we're going to do some composition with a graph. So remember, when we do this, when we did this with equations, okay, so we said that this was my input, and then once we did the input, we got an output, and then we took that output and put it into the next function. So you're going to do the exact same thing with a graph. You just got to make sure you look at the right graph. So we're going to start with the g graph, and we're going to look at negative 4. So I'm going to go to, remember this is my x value, that's my input. So I'm going to go to x at negative 4, and it's going to give me an output of 3. So this is your input, this is your output. So we know that g of negative 4 equals 3. So now I'm going to take that 3, and that 3 is now going to become my input for f of x. So we're going to go over here to f of x, and we're going to find f of 3. So we're going to go to 3, and we're going to connect to the graph. So this is my input, and I get an output of negative 6. So my final answer here is going to be negative 6. So the key to these is pay attention to which graph is which, and then make sure you do the input output and then switch graphs as you need to.